I've always thought if assignment 56 IC double I could talk, it would say roars with bestial vigor. Because that's certainly the way I feel by the time I'm done with this, that I have walked up to the top of Mount Lemon from downtown. Roar. All right. Of course, littered along the way are the corpses of the weaker who just started but couldn't make it. So let's go. How many problems are there? My God, there's 66 problems here. All right. And again, I recommend you actually do this before you watch this video. And then we can compare answers. And I noticed that the directions say big C, little r, little p are constants. So the derivative of a constant is 0. And I'm supposed to find y prime for numbers 1 to 29. Okay. 1. Y equals 3 x to the fourth minus 3x squared plus 5 to the second times the derivative of the inside, 4x to the third minus 6x. Okay. 2. Y equals cosine of tangent x. Okay, so y prime, derivative of cosine is negative sine, leave the inside alone, times the derivative of the inside. Please remember to be looking here and not here, because often when students look here for what to take the derivative of next, they then say, let's take the derivative of this. But no, there's no secant squared in here. There's going to be the derivative of the outside function times the derivative of the inside function. That's what we have. That's why we're done. So look here, not here, to inform taking derivatives. Okay. 3. Y equals square root of x plus 1 over cube root of x to the fourth. Yeah. Remember how in pre-cal I said I'm not really fond of radicals? Yeah, I'm not really fond of radicals. X to the 4 thirds, and that's a negative because it's in the denominator. So I'm getting rid of my radicals, and I am going with rational exponents, and the world seems so much happier. And, I'm not going to tell you to get rid of your radicals. Well, maybe I will, but if you want to use radicals, use radicals. So much easier. I don't think I'm going to take the time to simplify things on this because there's already 66 problems to do. Number 4, y equals 3x minus 2 over square root of 2x plus 1. Okay, and it might be easier in your brain if you called that 2x plus 1 to the 1 half. All right, so y prime is going to be low d high minus I d low all over low squared. Well, when I square the square root, I'm just going to end up with that. Yeah, I could factor that out. I could cancel those. There'd be a tidy what's left, but I'll leave that to you because I'm moving on to number 5 because somebody wrote a worksheet with 66 problems on it. All right, y equals 2x times x squared plus 1 to the 1 half. This is product rule, so y prime is going to be 2 x squared plus 1 to the 1 half plus 2x times the derivative of this, 1 half x squared plus 1 to the minus 1 half. Please don't forget that, times the derivative of the inside. Okay, and again, opportunities for canceling and factoring abound. That is in fact why we did all that practice in pre-cal of those problems, because you're going to be seeing them here. And in chapter 5, you're going to be setting these derivatives equal to 0. Okay, problem 6, we have y equals e to the x 1 over x squared plus 1. No, e to the x over 1 plus x squared. There we go. So y prime with the quotient rule, low d high minus high d low over low squared. I really want to take this further because I can factor that out, and then I have a trinomial, and it looks like that trinomial even factors. Like it's a perfect square trinomial. So what would that be? That would be x minus 1 squared over x squared plus 1 squared. Oh, but no, there's no canceling out. Okay, 7. Y equals e to the sine of 2 theta. Oh, okay. So we know that y prime for an exponential is itself times the derivative of the inside function. Derivative of sine is cosine, leaves the 2 theta alone, times the derivative of the innermost 2 theta. 8. Y equals e to the minus x squared minus 2x plus 2. Sure looks like a product rule to me, but you could always move this to the bottom and do quotient rule. Okay, so what's y prime? Negative e to the negative x times x squared minus 2x plus 2 plus e to the minus x times 2x minus 2. Yeah, then factor that out and distribute that negative, combine like terms. Sure. It's very powerful, that force of simplifying, but I'm going to fight it and just keep going. Okay, 9. Y equals x over 1 minus x squared. So y prime is going to be low d high minus high d low over low squared. Plus 2x squared minus 1x squared is x squared plus 1 on top, and on the bottom, 1 minus x squared to the second. Okay, how about 10? 10 says y equals sine inverse. Y equals sine inverse of e to the x. So we know then that y prime is going to be 1 over square root of 1 minus stuff squared. Yes, that really does say e to the 2x times the derivative of stuff. Okay, so why is that e to the 2x? Well, think about it. We've got stuff squared. When I raise a power to a power, I multiply it. That's why that's a 2x. Okay, there's problem number 10. Problem 11. Y equals x e to the negative 1 over x. Ew. No. We love all the functions. Don't be prejudiced. Y prime equals 1 times e to the minus 1 over x plus x times the derivative of e to the is e to the times the derivative of that inside function. And I'm going to think about negative 1 over x as negative x to the negative 1. So bring down that negative. Ooh, negative times negative is positive, and subtract 1. We'll get x to the minus 2. What was it? In fact, ooh, look, a little cancel, and I could factor that out. So, don't tell. I said I wouldn't do this. Plus 1 over x. Because that x is going to cancel one of those, and I'll have x to the minus 1. That's what that is. Okay, 12. Y equals x to the r e to the px. So y prime, with the product rule, r x to the r minus 1 times e to the px plus x to the r times e to the px times p. This is power rule, so I bring down the r and subtract 1 times that plus that times the derivative of that. We know the derivative of that is itself times the derivative of the inside p. Okay, And that was 12. How about 13? 13, we have x y to the fourth plus x squared y equals x plus 3y. Okay, product rule, let's go. We've got 1 y to the fourth plus x times 4y to the third. Don't forget the dy dx plus, so all of this is the derivative of now our plus sign. And now another product rule, 2xy plus x squared times the derivative of that with respect to x equals, derivative of that is 1, and the derivative here is 3 dy dx. Okay, so let's put all the dy dx stuff on one side and all the not dy dx stuff on the other, and I'm going to have 4xy to the third plus x squared minus 3 dy dx equals negative y to the fourth minus 2xy. And so to get dy dx by itself, I'm going to have to divide both sides by 4xy to the third plus x squared minus 3. And there's my answer to number 13. 14. 14 says y equals ln cosecant 5x. Come on, be thankful I didn't say inverse cosecant. All right, y prime 1 over stuff times the derivative of stuff. The derivative of cosecant is negative cosecant. You know, some people, because they say negative cosecant cotangent, they write this. But we know it's cosecant cotangent of stuff. So watch out for that 5x, and don't forget we need the derivative of the innermost 5x, which is going to be times 5. Okay. And that was 14. 15. 15. Ooh, y equals secant. God, why have you forsaken me? 1 plus tangent to beta. All right, so y prime, low d high, derivative of secant, times the derivative of the inside function. Wow. But wait, there's more. Minus high d low. Derivative of that is 0. The derivative of this is secant squared. Leave the inside alone. Times the derivative of the inside. All over 1 plus tangent to beta squared. Yeah, we could do a little. Yeah, I'm not going to simplify that. I'm sorry. If it shows up on a test, I'll do it on a test, but I'm not going to do it now. I'm moving on to 16. We've got x squared cosine y plus sine 2y equals xy. So I'm going to have 2x cosine y plus x squared times negative sine y times dy dx. Yeah, here I was taking the derivative of that plus the derivative of that needs the dy dx. And here I'm going to have cosine 2y times the derivative of the inside, which is 2 dy dx. And then we get to our equal sign, and now we do the product rule on the other side. 1 times y plus x times dy dx. Okay, let's move all the dy dx to one side and all the not dy dx stuff to the other. So I have 2x cosine y well, maybe I'm going to just move the dy dx stuff over there. So I'm going to have negative x squared sine y plus 2 cosine 2y minus x dy dx equals y minus 2x cosine y. So let's divide both sides by negative x squared sine y plus 2 cosine y minus x. And, oh, that's good. And then over here, we've got that same thing, negative x squared sine y plus 2 cosine y minus x. Yikes. Use more paper. Don't squeeze it tiny. That's bad modeling on my part. 17. Y equals e to the cx. Remember, c is a constant. C sine x minus cosine x. So, product rule. C e to the cx. C sine x minus cosine x plus this times the derivative of this. Derivative of sine is cosine, so c cosine x, and the derivative of minus cosine is plus sine x. I kind of want to factor this out and see where this goes. Sorry, I am going to go there. This will be c squared sine x minus c cosine x plus c cosine x plus sine x. Did I distribute that c to both of those? Yes, I did. And so these cancel. I can take out a sign now. So e to the cx sine x, leaving me c squared plus 1. Well, that's really quite tight. Okay. 17. How about 18? 18 says y equals the ln of x squared e to the x. So, derivative of ln of stuff is 1 over stuff times the derivative of stuff. Derivative of stuff requires product rule. I could factor out an x e to the x. Oh, there'd be some canceling then, wouldn't there? Huh, well, yeah, I can't help myself sometimes. X e to the x, leaving me with 2 plus x over x squared and e to the x. These cancel, this cancels. I have 2 over x plus 1. Whoa, that's so tidy. I'm kind of glad I went down that road. 19. Log base 5 of 1 plus 2x. Okay, so we know that the derivative of log of stuff is 1 over ln of the base times stuff times the derivative of stuff. 20. Y equals ln of x raised to the cosine x power. And of course, this is logarithmic differentiation. Now, these ln's don't cancel out, and no, they don't become ln squared. So, what do we have here? We've got ln of y equals cosine x times the ln of the ln of x. So when I use implicit differentiation here, take the derivative of ln of stuff. I have 1 over stuff times derivative of stuff. Here I have a product rule, negative sine x ln of x plus cosine x times derivative of ln of stuff is 1 over stuff times the derivative of stuff. Still got to multiply both sides by y, and remember y was originally in this problem ln x raised to the cosine x power. So dy dx will be ln of x raised to the cosine of x times negative sine x ln of ln of x plus cosine x over x ln of x. Yay! All right. Hey, so we're about a third of the way done. That's kind of cool. 21. Y equals ln sine x minus 1/2 sine squared x. All right, what you got going? Do we have anything else? Yeah, that's it. So y prime, derivative of ln is 1 over stuff times the derivative of stuff minus, I bring down that 2, I leave the inside alone, I come back and take the derivative of the inside. Well, it wasn't so bad. So cotangent x minus sine x cosine x. Cool. 22. 22. Oh my goodness. Mr. Kukla, why do you hate us? 2x plus 1 to the third, 3x minus 1 to the fifth. Well, it's a beautiful day in the neighborhood. Yeah. So, I'm just going to laugh a little bit because that'll help. Low d high minus high d low. Now, let's talk about d low. D low is a product, so I need to use product rule. D low, so that's going to be 2x plus 1 to the second times 2 times 3x minus 1 to the fifth plus 5 3x minus 1 to the fourth times 3 times 2x plus 1 to the third. All over 2x plus 1 to the third, 3x minus 1 to the fifth squared. Wow. Low d high minus high d low. The derivative of low is product rule. So there's derivative of the first times the second plus the first times the derivative of the second. Don't forget all over low squared. And yeah, you could just, apply that sign to both of those. But I'm moving on quick because that problem, wow, that's intense. 23. Y equals x tangent inverse 4x. So y prime, 1 times tangent inverse 4x plus x times the derivative of inverse tangent is 1 over stuff squared plus 1 times the derivative of stuff. Don't forget, if you do take this further, you got to square that 4 as well as the x. Okay, 24, y equals e to the cosine x plus cosine of e to the x. There's a nice symmetry there. So the derivative of e to the is e to the times the derivative of that inside cosine function plus the derivative of cosine is minus sine, leave the inside alone, times the derivative of the inside. 25. We've got ln secant 5x plus tangent 5x. So these mean that ln isn't going to be eating any negative stuff, and that's fine, but no, it's not really going to affect anything I do for the purpose of derivative. If this were honors AP Calc, maybe it would. So y prime, 1 over stuff times the derivative of stuff, derivative of secant 5x, tangent 5x times 5 plus the derivative of tangent so all this stuff is on top. You know, I see a 5 secant 5x and I see a 5 secant 5x. And so if I take out a 5 secant 5x, I'm going to be left with a tangent 5x plus, ooh, I took one of these, I still have one. And then on the bottom, we've got secant 5x plus tangent 5x. Those are the same. And so that's a very tidy y prime. Okay, 26. Y equals 10 raised to the tangent of pi theta. So y prime, remember though, the derivative of an exponential is itself times the ln of the base times the derivative up here, which is secant squared pi theta times pi. 27, excuse me, y equals cotangent 3x squared plus 5. Y prime, derivative of cotangent is negative cosecant squared, leave the inside stuff alone, times the derivative of that inside stuff. 28. Oh, goodness. Y equals e to the cosine x plus, nope, that's 24. Thought that looked familiar. 28. Ah, the 9th level of hell. Tangent. Sine of tangent of square root of 1 plus x to the third. Okay, so y prime, derivative of sine, cosine, leave that inside stuff, times the derivative of tangent, secant squared, leave that inside stuff, times the derivative of square root, times the derivative of the innermost 1 plus x to the third. Done. 29. Oh, isn't that interesting? 29. Y equals arctan of arcsine of square root of x. Okay, so remember the derivative of inverse tangent is 1 over stuff squared plus 1. 1 over stuff squared plus 1 times the derivative of stuff. So that's 1 over square root of 1 minus square root of x squared is x times the derivative of that innermost, which will be 1/2 x to the minus 1/2. Yeah, so that's not an exponent, so don't make that to the negative 2 power. And that doesn't affect this, that is affecting this. So you just leave it alone and walk away. Please, quickly. All right, 30. Ooh. Says find y double prime of 0. Well, if y equals 2x minus 1 to the negative 5th, then y prime is going to be negative 5, 2x minus 1 to the negative 6. Remember, you're subtracting 1 when you take a derivative, times the derivative of the innermost function. And then y double prime, I'm going to have 30, 2x minus 1 to the negative 7. I guess I kind of want to put that there and say 60 times 2. So let's plug our 0 in now. And we have 120 over 2 times 0 minus 1 to the 7th. That's going to be negative 1. Negative 1 to the 7th is a negative 1. And so I get negative 120. 31. Y equals, no, it's not y equals. It says find y double prime if x to the 6th plus y to the 6th equals 1. Okay, so 6x to the 5th plus 6y to the 5th to y to x equals 0. So dy dx is going to be negative 6x to the 5th over 6y to the 5th. And I can cancel those. And that's about it. But I need the second derivative. So now I'm going to use quotient rule for the second derivative. And that's going to be low d high, which is negative 5x to the 4th, minus high d low, all over low squared. Remember, we can't leave that in our answer. We have to replace this with dy dx. Negative x to the 5th, y. Yeah, I kind of want to tidy this up, but yeah, I think I'm going to get into that urge. There's no good reason for it. Negative 5x to the 4th, y to the 5th. Minus a minus is plus x to the 10th. There's a 5. And these 4 cancel out 4 of these, and so I have a y there. All over y to the 10th. Okay, so what if I multiplied by y over y, and then flipped and multiplied? So I'm going to have 5x to the 4th, leaving me negative y to the 6th plus x to the 6th over y to the 11th. I think that's as far as I can go. Don't do the difference of squares there, please. Okay. 32. Ooh, almost halfway done. 32 says that f of t equals the ln of t squared plus 1. And we're asked to find the derivative of the given function. All right, so f prime is 1 over t squared plus 1 times the derivative of stuff. 33. F of x equals the ln of minus x. F prime then is going to be 1 over stuff times the derivative of stuff. That's negative x. That's the derivative. Don't lose that negative sign. Very common to lose that negative sign. 34. F of x equals the ln of e to the 2x. So remember, the derivative of ln of stuff is 1 over stuff times the derivative of stuff, which is itself, times the derivative of 2. Isn't that interesting? The answer here is 2. How come? Well, think about it. You've got this ln, and inside it, and so you're going to use that power property of logs to rewrite this, and you're going to say, well, ln of e is 1, and so that's the function, and the derivative is that. Okay, 35, I got y equals e to the ln of 2x squared plus 3. No, I mean really, these are inverses. They cancel each other out. There's my function, so my derivative should be 4x. Many people, however, will not do that, and they will in fact go the long way. So let's go the long way. Derivative would be itself times the derivative of ln is 1 over stuff times the derivative of stuff. Okay. Mr. Kukla, that doesn't turn into the other one. Well, actually it does, because look, e raised to the log base e cancels. And so now I have 2x squared plus 3, 1 over 2x squared plus 3 times 4x. Doink. There we go. So why not just go there at the beginning? I know, you weren't comfortable with your algebra. Where are we? We are on 36. And f of x here appears to be the ln of x raised to the negative 1. So f prime, negative 1, ln of x to the negative 2, times the derivative of ln of x, which is 1 over x. So I think this could be rewritten as negative 1 over x ln squared x, if you were in a tidying frame of mind. 37. I will say that these problems are feeling much easier than the ones from 22 to 31. Ooh, those are exciting. F of theta equals ln cosine theta. So f prime of theta, 1 over stuff, times the derivative of stuff. And so we get negative tangent theta. 38, f of x equals the ln of 1 minus e to the minus x. So f prime, 1 over 1 minus e to the minus x, times the derivative of 1, which is 0, and the derivative of this will be negative e to the minus x, times the derivative up here, which is negative 1. So, yeah, remember, I can't flip just this up to the top. I would have to make a common denominator and then flip the multiple. So instead, I'm just going to walk away onto 39 now. 39. F of alpha equals the ln of sine alpha. So f prime of alpha is going to be 1 over sine alpha times the derivative of sine, which is cosine, and so I get cotangent alpha. 40. 40 says f of x equals the ln of e to the x plus 1. I know then that f prime is going to be 1 over stuff times the derivative of stuff. No, these can't cancel. You have to be able to take it out of 3. 41. F of t is the ln of the ln of t plus ln of ln of t. You wily kukla. So f prime is going to be derivative of ln is 1 over stuff times the derivative of stuff plus, now, ln of 2, there's no variable here. The ln of 2 is a number. The ln of a number is a number. Unless that number is 0 or negative. But ln of 2 is not 0 or negative. So this is just a number, and the derivative of a number is 0. So there's my answer, 42. 42 says f of x equals ln e to the 7x. Yeah, like so, let's do it. And so if f of x is 7x, then f prime has got to be 7. But now I hear you. You don't like that. But really, you should like that. So instead, you're going to have me do 1 over e to the 7x times the derivative of e to the 7x, which is itself, times the derivative of the inside function. These cancel. There's my 7. Okay. 48. No. 40. Well, that was 42, so this must be 43. F of x equals e to the ln of x plus 1. All right, I'll do it your way first. E to the ln of x plus 1 times the derivative of ln of x is 1 over x. Derivative of 1 is 0. So there's my answer. It's e to the ln of x plus 1 all over x. But I'm thinking about this. What allows me to add exponents? When the bases are the same and I multiply, I can add those exponents. So I can rewrite this problem like this. Okay, so that's going to be e to the ln of x times e to the 1. Now, why did I want to do that? Well, e raised to the power of log base e cancel each other out. And so I have x times e. Well, that doesn't look like x times e. Yeah. Kind of want to pull out a calculator and graph it. Well, let's see. So this is going to be e times e to the ln of x over x. And that gives me e x over x. Ooh, that's just e, but that's ex. Did I miss something? That's a constant. That's just x. Kind of want to keep looking at this. Derivative of the inside. Cancel x. Let's, yeah. Why don't you figure out what's happening here and put a message in the comments down below. Okay. So many ln's. That was 43, so 44, y equals ln cosine w minus 1. So y prime 1 over cosine w minus 1 times the derivative of cosine times the derivative of w minus 1. 45 f of t equals the ln e to the ln of t. All right, well, these should cancel and give me ln of t, and so I should then have f prime equals 1 over t. But let's try it the long way. Derivative of ln is 1 over stuff times the derivative of this inside thing times the derivative of this. Oh, yeah, that works. 46 f of y equals sine inverse y squared. Okay, notice my function is a function of y, it's not a function of x, so this is not implicit differentiation. When I take the derivative of y, it's with respect to y, so I'm going to have dy here. So f prime is going to be the derivative of inverse sine, which is 1 over square root 1 minus stuff squared times the derivative of stuff. And what I was saying before is if you thought about this as the power rule and came back and took the derivative of y with respect to y, look, there's no dy dx there. So I'm going to end up with 2y over square root 1 minus y to the fourth. All right. That was 46, so 47. 47 says tangent inverse 3t minus 4. So y prime is 1 over 3t minus 4 squared plus 1 times the derivative of the inside, 3. 48, g of alpha is sine of inverse sine of alpha. Can't we just cancel those and then say g is a, and so that g prime equals 1? But I guess we're going to go with the lone one. Huh? Okay. So g prime equals derivative of sine is cosine, and then here we have sine inverse of alpha times the derivative of sine inverse, which is 1 over square root 1 minus stuff squared, times the derivative of alpha with respect to alpha is 1. Yeah, that doesn't look like 1. But g is equal to a, and therefore g prime should be 1. You know, I think this requires me to draw a triangle. So this is a1, this is square root of 1 minus a squared. So this is draw the triangle. And there's my theta. So this says the cosine of theta. But theta is the theta in this picture. And that theta is what theta? This theta. I want the cosine in this picture. So the cosine in this picture is square root of 1 minus a squared over 1. Oh, there it is. No, I've never seen anyone have to do that on the AP exam. But we could do it because we drew a lot of triangles last year. All right, so let's take a look at 49. Y g of t equals e to the tangent inverse of 3t squared. So we know that g prime is going to be e to the times the derivative of that inside function. Derivative of tangent inverse is not secant squared. It's 1 over stuff squared plus 1 times the derivative of stuff. Okay, 50. G of t equals cosine ln of t. So g prime minus sine, leave the inside alone, times the derivative of the inside. 51. H of z equals z to the ln of 2. Now, the ln of 2 is a number. This is z raised to a number, just like x raised to a number. How do I take the derivative of that? H prime of z is going to be ln of 2 times z to the ln of 2 minus 1. Okay, it's just the power rule, but it's the power rule sort of in disguise, because usually we do the power rule with x raised to a number, not z raised to a number. And our numbers aren't usually things like ln of 2. They're numbers like 2. Okay, 52. 52 says h of w equals w inverse sine w. So h prime with the product rule, 1 times sine inverse w plus w times 1 over square root of 1 minus w squared. You could, of course, always then take the derivative of w with respect to w, but that's just going to be 1. All right, 52, done. 53. 53 says f of x equals cosine arc sine x plus 1. Did you want to do this as a draw triangle problem? All right, well, let's try that. So, this is x plus 1, this is 1, this is the square root of 1 minus x plus 1 squared, which I guess is the, we're going to cancel negative x squared minus 2x. Okay, and I want the cosine in this picture. So cosine is adjacent over hypotenuse. That's my adjacent over 1. Fabulous. So f of x is square root negative x squared minus 2x. So f prime is going to be 1 half negative x squared minus 2x to the negative 1 half times the derivative in here, negative 2x minus 2. I guess you could pull out a negative 2 here and cancel with that 2 there, so you'd end up with just a negative, and this would be an x plus 1. All right, so that's one way to think about the problem, but the way most people do this problem, f prime, derivative of cosine is minus sine, times the derivative of inverse sine is 1 over square root 1 minus x plus 1 squared times the derivative of x plus 1, which is 1. Okay, and look, this will cancel, and I'll have that negative out in front, and this stuff over that. Yeah, same. 54. 54 says, whoa. Oh, 54 has an A and a B. 54a says find h prime of 2. And I'm told in 54 that h equals f times g. Okay, so I need h prime, which is going to be f times g prime plus g times f prime. And I want h prime of 2, so that's f of 2 times g prime of 2 plus g of 2 times f prime of 2. So I was told that f of 2 equals 3, g prime of 2 is 4, plus g of 2 is 5, and f prime of 2 is negative 2. So that's going to be 12 minus 10, or 2. So h prime of 2 is 2. Okay, that was part A. What about part B? B, for number 54, says find big F prime of 2. And we're told that big F prime is f of g of x. So big F prime is going to be f prime, leave the inside alone, times g prime. And big F prime of 2 then would be f prime g of 2 times g prime of 2. G of 2 is 5. F prime of 5 is 11. G prime of 2 is 4. And so I get 44. All right, 54 is done. 55. Similar problem. 55a. 55a says p prime of 2. So if p is equal to f times g, then P prime is F times G prime plus G times F prime. And so P prime of 2 is going to be F of 2, G prime of 2, plus G of 2 times F prime of 2. So let's get these values out of the problem. We're told that, no, we're not. What? Oh, whose graph is shown? Here's the graph. All right, so I need F of 2. This is the F graph here. F of 2 is 1. G prime of 2. So here's the G function. And I need G prime, which is the slope of G. Well, this goes up 2 and over 1, so the slope of G is 2. G of 2 is 4, and F prime of 2 is the slope of F at 2. Well, this goes down 1 over 1, so slope is negative 1. So P prime of 2 is going to be negative 2. All right, that was doable. Just had to find the graph. Part B, Q prime of 2. Q prime of 2. And we know that Q is equal to F over G. So Q prime, low, D high, minus I, D low, over low squared. And I want Q prime of 2 so G of 2. According to the graph, G of 2 is 4. F prime of 2 is negative 1. Minus F of 2 is 1. And G prime of 2 is the slope of G of 2. G of 2 is 4. 4 squared is 16. So I have minus 6 over 16, or minus 3/8. Part B, done. How about part C? C prime of 2. Okay, we're looking for C prime of 2. And I'm told that C is equal to F of G of X. So C prime is going to be F prime of G of X times G prime of X. So C prime of 2 is F prime of G of 2 times G prime of 2. G of 2, we said, was 4. So this is F prime of 4 times G prime of 2. G prime of 2 is 2, F prime of 4. Well, let's take a look at the graph. Yeah, that's going to be hard for me to say. I really needed a point labeled over there called 4, 1. So I'm going to say the slope at 4 on F is 1. And I'm going to go with C prime is 2. Okay. But I should fix that. What's next? 56. 56 says F equals x squared times G. So F prime is going to be 2x times G plus x squared times G prime. Stop. Done. Walk away. What did the directions say? Find F prime in terms of G and G prime. You're not expected to do any more here. 57. F equals G of x squared. So F prime, I take the derivative of the outside G function, I leave the inside alone, and then I come back and I multiply by the derivative of the inside function. How about 58? 58 says that F equals G squared. So F prime, bring down that 2, leave the inside function alone, subtract 1, times the derivative of the inside. 59. F equals G of G of X. F prime equals derivative of the outside, leave the inside alone, times the derivative of the inside. 60. 60 says f equals g of e to the x. So f prime is going to be the derivative of the outside, leave the inside alone, times the derivative of the inside. This sort of feels like the cool down to a workout, doesn't it? You know, pushed really hard. And now these are just sort of gentle and kind. 61. F equals e to the g of x. So f prime, derivative of e to the is e to the times the derivative of that inside function, g prime of x. 62 says f equals ln of g of x. And so we know f prime is 1 over stuff times the derivative of stuff. And 63. 63 says f equals g of ln of x. So f prime, take the derivative of the outside, leave the inside alone, times the derivative of the inside. Not so bad. Okay, 64. At what point on the curve y equals ln x plus 4 squared is the tangent horizontal? Well, I know a horizontal tangent has a slope of 0. So what I'm really wondering is, when is this derivative equal to 0? Well, let's find the derivative. Y prime equals 2 ln x plus 4 to the 1 times 1 over stuff times 1 derivative of x is 1. Okay, so when is this equal to 0? Well, let's tidy it up a little bit. We've got 2 ln x plus 1 over x plus 4 equals 0. So I multiply both sides by x plus 4, and I see that the denominator still doesn't play a role. Divide both sides by 2, exponentiate. I get x plus 1 equals 1. Think about it graphically. Absolute value shifted left 1. Horizontal line, y equals 1. Two solutions. X equals negative 2, x equals 0. At those places, this thing has a horizontal tangent. You know, I kind of want to see it. So let's graph it and see. Y equals parentheses ln of parentheses x plus 4 close two parentheses 3 parentheses squared. And I want to graph this function, so I'm going to do zoom standard. At negative 2, I see a horizontal asymptote. I mean, a horizontal tangent. I don't see a horizontal tangent at 0, though. Huh. Well, let's think about this. Yeah. Let's think about this. That worked. That didn't work. If I go back to the original problem, I can put a 0 in. Why wouldn't that work? It's not undefined. 2 ln times 1 over stuff. Multiply both sides. I want to know when the derivative is 0. E over 0. Those cancel. Oh, well, that's very interesting. So I'm going to go here and type in deriv. Sometimes you should just walk away from a fight. But most times you should just walk away from a fight. X, X. Okay, so I'm going over to the table, and I'm going to look at the derivative at x equals -2. And at -2, my calculator says that the derivative is ln of 2. Uh-oh. Well, I feel like I got something typed in wrong. I wish my eyes were working a little better. Okay, start again. Parentheses. ln parentheses x plus 4. Close parentheses on the ln. Close parentheses, put the square in. Okay. So, zoom standard. Yeah, I don't see a horizontal tangent there, but I think I do here. Let's see if there's a 0 there. It'd be funny if there were 2 zeros really close together. Zoom. Enter. Is that crossing once or twice? You know, if you've made it this far through this video, you're sort of accustomed to me being, you know, a prisoner of my whimsy. But what? Yeah, just so weird. Is that 0 there? If it was 0 there, why was it giving me this other thing? I'm sure the answer is very obvious and clear. Okay, so go over to the table. I'll type in a 0. And that's not right. Oh, I need to have the derivative turn off. Okay, turn off the original function. And go over to the table. -2 and 0. Look at that. At both of those points, the derivative says ln of 2. I don't want to know ln of 2. Why is it saying ln of 2? That's very interesting. I feel like I'm missing something really, really obvious. Okay. Y prime equals 2 ln x plus 4 times 1 over x plus 4 times 1. And I want to know when this is equal to 0. So that's the same as when ln of x plus 4 equals 0. So x plus 4 equals 1. X equals -3. Well, I don't know what the hell I did last time. That's the place. Wow, there was some sort of sleepy over Kukla. Maybe it's because I just done 63 other problems. 65. It wouldn't be complete without writing the equation of a tangent. So Find the equation of the tangent to the curve y equals e to the x that is parallel to the line x minus 4y equals 1. So x minus 1 equals 4y. I see 1/4 x minus 1/4 equals y. I want to be parallel to this line. This line has a slope of 1/4, so I'm looking to see when this curve has a slope of 1/4. In other words, I'm wondering where y prime is equal to 1/4. So the derivative of e to the x is e to the x. And I take the ln of both sides, bring this down, get x equals ln of 1/4. Of course, you could always write that as ln of 4 to the negative 1, or better yet, 2 squared. So you can have ln of 2 to the negative 2, and then you could bring that down and say negative 2 ln of 2. So when x equals this, the tangent line will be parallel to this line. Okay, do we have to write the equation? Oh, we do have to write the equation of the tangent. So wait. Oh, I need to find the ordered pair here. There's the x value. Don't I need a y value? Y value is e raised to the x. This is my x. I suddenly don't like this x. I suddenly want to go back to this x. Okay, why do I want to go back to this x? Because when I take this x and I plug it into that function, e to the ln of 1/4, these are going to cancel and give me 1/4. So my ordered pair then is ln of 1/4, comma 1/4. And my slope is 1/4. Okay, so y minus 1/4 equals slope 1/4 x minus ln of 1/4. And you might want to tidy that up. But no, the point is we can just walk away here. And finally, number 66, y equals e to the x, and I want to write the equation of the tangent that passes through 0, 0. So if we think about this, there's somewhere a tangent line that passes through 0, 0. I don't know what the point of tangency is. I can only speak about it in general terms. But when we did this one in class in this chapter, we said at the point of tangency, two things are true. The ordered pair on the tangent line and the ordered pair on the curve are the same, but also the slope of the tangent line and the slope of the curve are the same. So the slope of the tangent line, I'm going to use the slope formula with these two ordered pairs, e to the x minus 0 over x minus 0. That's the slope of the tangent line. The slope of the curve is called its derivative, and that's e to the x. So what I want is the slope of the curve to equal the slope of the tangent line. E to the x equals e to the x over x. I multiply both sides by x. Equals e to the x. I'm going to subtract e to the x from both sides. I'm going to factor out an e to the x and be left with x minus 1. Now, e to the x equal to 0? Never. There's a horizontal asymptote at 0. This thing never crosses the x-axis. When does this equal 0? Well, when x equals 1. And if x equals 1 and y is e to the x, or e to the 1, then the ordered pair here is 1 comma e. The other thing I need to know, though, is what's the slope at that point, right? In order to write the tangent line, I need an ordered pair. I also need a slope. Well, you can plug that 1 in here for the tangent line, or in here for the curve. I prefer here because it's less work. Y prime of 1 equals e to the 1. So my tangent line equation then, y minus e equals e x minus 1, which I think is just EX, right? Because this is going to be minus E plus E, they'll cancel, and there's my tangent line equation. Wow, 66 problems. No worries. And how long did that take? Only an hour and a quarter. That's almost a problem a minute. That's pretty good. Some of those problems had, a bunch of parts. Anyway, I hope you're feeling more comfortable with this stuff, and I'm going to go put that f of 4, f prime of 4 equals 1 on that graph, and I think I should move that graph up a little bit so that you could actually see it when you're at problem number 55. Okay, have a great day, everyone. See you soon.